We see ratios used a fair bit, whether it be in the house while we're cooking using recipes, or maybe even if we're mixing paints together to make a particular shade, or even on a scale of a map, just to name a few. But what exactly are ratios? Well, today we're going to find out. Now in front of me right now, I have a series of red and blue balls all mixed together. Now ratios can be used to tell me how many red balls I might have here in comparison to blue balls. For example, if I were to count the total number of red balls that I've gotten here, I will have 6 of them. So I can actually say that I've got 6 red balls compared to the number of blue balls which I have, which is 3. And at the top here, what I've recorded is the number of red balls in comparison to blue balls is 6 to 3. Now ratios can be thought of very similarly to fractions, where we can simplify or reduce this ratio down even further. So for example, if I divided both these values by 3, I'd be saying that for every 2 red balls that I have 1 blue ball. To explain that, if we divided these blue balls into one group each, what I'm saying is for every 2 red balls that I've got, I have 1 blue ball. But that's not the only ratio that we can get out of this. What if I wanted to know the total number of red balls I have in this problem compared to the total number of balls there are present? Well, I know that I've got 6 red balls in this collection, and the total number of balls I've got here is 9. So the ratio of red balls to the total number of balls is 6 to 9. But like before, we can simplify this down. We look for the highest value that divides into both 6 and 9. In this case, it's 3 again. So 3 divides into 6 twice, so for every 2 red balls we've got, 3 divides into 9 3 times, we've got 3 total balls. Likewise, blue balls can also be represented as a ratio to the total number of balls here. For example, I've got 3 blue balls, and if I count the total, as it was before, there are 9 total balls here. So the ratio of blue balls to the total number of balls is 3 to 9. But if we simplify that down, that's going to be 1 blue ball for every 3 balls there are total. But to help make sense of these two, let's quickly divide it back into the 2 to 1 ratio that I exampled earlier. What this red to total ratio is saying is for every 2 red balls that are present, I have 3 total balls present, which you can see in each one of these examples. The bottom one here, the blue to total, is saying for every 1 blue ball there's present, there's 3 total balls present, and you can see that very clearly here. So what we've learnt so far are ratios are a comparison between one amount with another. We can treat them like fractions in a way and simplify them right down. But why might we want to do this? Well, let's investigate. What if we were mixing paints to create a particular shade of purple that we needed? And the ratio between the red paint that we're mixing with the blue paint is 2 to 1. This ratio is like the ratio that we had earlier, where our red to blue is 2 to 1. What I'm wanting to know is, if I started with 6 buckets of blue paint, how much red paint would be needed? So in essence, what I'm saying is, if this represented a bucket of blue paint, how much of this red paint would I need if I had 6 of these? Well, we know that the ratio between red paint and blue paint is 2 to 1. We also know that we want to get the blue paint to have 6 buckets of it. What we don't yet know is how much red paint we want. But to figure this out, we need to look at what did we multiply by to get from 1 through to 6 buckets of blue paint. In this case, we multiplied by 6. So to work out how much red paint we need, we also need to multiply this side of the ratio by 6. So the red paint is going to be 2 times 6. Therefore, we're going to need 12 buckets of red paint. Okay, so what if I started with 500 millilitres of red paint? How much blue paint would I need? Well, I know the ratio between red paint and blue paint is 2 to 1. I know that I've got 500 millilitres of the red paint, and I need to know how much blue paint would be needed. Now I have to look at what do I need to multiply the 2 by to get to 500. In this case, I'm multiplying by 250. And what I do to this side, I must also do to the other side. So I've also got to multiply this side by 250. So the amount of blue paint that I'll need will equal 1, because that's my ratio, times 250. Therefore, the amount of blue paint I will need is 250 millilitres. Now there are other ways that we can use, but I'll cover that on a later video. For now, let's have a look at a practice problem. Now for your practice question, I've decided to stick with the paint example. What we've got is a mixture of green paint with yellow paint, and I want you to work out the ratio between green paint and yellow paint, also the ratio between yellow paint and the total amount of paint, and then decide how much of the yellow paint you're going to need if you start off with 600 ml of green paint.